This lesson gives us basic rules for differentiation, which you're really going to appreciate after yesterday's lesson about finding the derivative using the fundamental sort of rule for calculus, that the derivative at a point in time on a curve is a limit as you get closer and closer to that point and you make the distance between them close to zero. And we found the slope then of that point as that distance came closer to zero by using the change in y over the change in x, because that's the slope formula. So we did the slope formula yesterday on it as a limit. All right, you're gonna like this today. So yesterday that took a long time to do one of those problems. You're gonna see today how quick it really is to do. So some basic rules for differentiation we're doing in this lesson: the constant rule, the power, constant multiple, sum and difference. We're going to briefly talk about derivative of sine and cosine, and then we're going to do some story problems with the rates of change. Okay, the first rule down here, the constant rule. A constant is just a number. We'll say maybe the number 8. The derivative, or f prime of x, is 0. And the reason for that is because, as we learned yesterday in the last lesson, the derivative is all about the slope at a point on the graph. Well, if it's a constant number, remember f of x is a fancy way of saying y. So this is the line, maybe y equals 8. Every single point on that line has a slope of 0 because it's a horizontal line. So if you have a constant number, the slope of it is just 0. So the derivative of it is 0. So whenever you see a number and you're taking the derivative, it's gone. And then on the next one, the power rule, it says x to the n. If you were to take the derivative of that, you pull the n in front, and then you take one less than the power. So for example, if f of x is equal to x to the 4th, f prime of x is equal to 4, and then one less than it, so 3, 4x to the 3rd. Let's combine that now with the next one, the constant multiple rule. And you might think this is not that important, and you'll see on a couple problems, and I'll talk about it in future problems, but if you've got a c in front of a function that you're taking the derivative of, you can ignore the c, and you just take the derivative of the function itself. So let me look at that with you. So if we had f of x equal to 5x to the 3rd, what we're doing when we take the derivative, f prime of that, we're taking not the derivative of 5, we're taking the derivative of the function. So f prime of that function, x to the 3rd. And the derivative of that, 3x to the 3rd, is 3x squared. By the power rule that was up above here, again, you pull the power out front and then take one less than it. So I pulled my power out front, the 3, and took one less than the 3, which made it 2, and then you multiply it together here, so you got 15x squared. So going quicker on it, if it was like 2x to the 6th, all you really have to do is take the power times the number out front, so 12, and then take one less than the exponent, so that would be to the 5th. Then the sum or difference rule says that you can take if something is all added and subtracted together, you can take each one of those terms individually. So for example, you had f of x equal to 3x to the 4th minus 2x to the 3rd plus 6. You can treat all three of those terms individually by the sum and difference rule. And I can take the derivative of all of them. 3 times 4, 12. 1 less than 4 is 3. 3 times 2, 6. 1 less than 3 is 2. And derivative of 6, gone. It's 0. So you're all done with that. Okay, on the next page, this one, now those last rules that we just did, honestly, I don't really think you need to make a flashcard for them because you're just going to get to know them. It's not going to be a problem. Maybe originally you're going to need to make a flashcard, but overall, not really. So these, though, you definitely are going to need a flashcard. So the derivative of sine is cosine. d dx of sine is equal to cosine. And then the derivative of cosine is equal to negative sine. All right, so we have some practice down here. On the first one, we have y equals 2x to the 3rd plus 6x squared minus 1. Again, this might be a good point for you to pause the video on these problems after I read the question to you so that you can try the problem before I do them. So the derivative of y prime, 2x to the third, 3 times 2 is 6, and then 1 less than 3 is 2. The next one, plus 6x squared, 2 times 6 is 12, and then 1 less than 2 is 1, and then the derivative of 1 gone. All right, the next one is where the constant multiple rule comes in handy. 23 says y equals pi over 2 sine theta. So the derivative of that, y prime, this is a constant in front. Pi is a constant. It's not a variable. It's a number. So we're not taking the derivative of it because it's not a variable. It's a constant. So we're going to leave it in front. And then we're going to take the derivative of sine. And the derivative of sine is cosine. So then you're all done. It's pi over 2 cosine theta. On the next one, we have y equals 7x to the fourth plus 2 sine x. So y equals 7 times 4, 28. X to the third, because you take 1 less than 4, and that's 3. Then you have, that's a constant out front, so plus 2. And then the derivative of sine is cosine. Again, 2 is a constant, so you leave it in front. And so that's just the whole answer is 28x to the third plus 2 cosine x. All right, on the next page, we're going to find the slope now of the graph of the function at the given point. Again, this is what we did yesterday that took us all day to do. On this one, we don't have a rule yet for how to do something to a power, a bigger thing. We know how to take the derivative of just an x, but not of a quantity in a parenthesis like that. So we're going to have to clean it up. So doing f of x, let's clean it up. We're going to do x minus 4 squared. It says f of x equals 2 times x minus 4 squared. So we're going to FOIL out the x minus 4. So FOILing it out, you get x squared minus 8x plus 16. Multiply across by the 2, so 2x squared minus 16x plus 32. And then if you took the derivative of that, because again, we're trying to find the slope. So finding the slope, you have to do the derivative. And again, that's all about what a derivative is. It's the slope at any point in time on the curve. So now doing f prime of x, 2 times 2 is 4, and then 1 times 16, 16, and then 32 gone. So that makes the derivative 4x minus 16. So at this point 2, 8, so at the point 2, 8, the slope is equal to f prime of 2. You plug in the x, because it's f prime of x, so plugging in the 2. It's going to give you 4 times 2 minus 16, which is negative 8. And then on your calculator, we want to check it here. So we're going to put it in the calculator. So 2 parentheses x minus 4 squared. And again, what you do is you go to calculate, second calculate, choice number 6, the derivative. And we wanted to know the derivative at the point x equal to 2. So then just type the number 2. And the derivative of that at that point in time is negative 8, which we just got. And you're thinking, well, now why did I have to do all the work? Because you have to show your work on your test sometimes. So you're going to have to do that. All right, overachieving. We're going to overachieve. They did not ask for the tangent line, but let me just remind you how to do the tangent line at that point. So again, the tangent line slices across the curve at one point and only one point, just at that point. And so going over here, putting in the point 2, 8, use the slope point formula, y minus y1 equals m times x minus x1. Again, I know there's other ways to find a line. This is just my favorite way. So y minus 8 equals that slope of negative 8 times x minus 2. I'm going to clean it up so I can put it in the calculator. So that makes it negative 8x plus 16. So y equals negative 8x plus 24 when you move the minus 8 over. So putting that in the calculator, y equals negative 8x plus 24 graph. So you can see it slices through at that point 2, 8, and there's your tangent line to the graph. Okay, the next one. Get to use some trig here. Again, I know it's like a fraction to you. It's going to be okay. We've got g of t is equal to negative 2 cosine t plus 5. All right, so again, they want us to find the slope at the point pi 7. So we got to take the derivative of it. So g prime of t is equal to the derivative, again, that's a constant, so I'm just going to leave that in front. And the derivative of cosine is negative sine. Oh, and then the derivative of 5, gone. And then, so we got a negative and negative, so that's positive 2 sine t. And so the slope at that point, pi 7, is g prime of t, and that is g prime of the pi. You probably didn't need to write all that, but then you put the pi into that, so that gives you 2 sine pi. And again, the sine of pi is 0, so the whole answer is just 0. Again, you need to know that pie chart, the unit circle. You need to know your unit circle for all the critical points on the unit circle. Just, you need to be quick at it. You need to just know that the sine of pi is 0. Personally, what I do is I always think about the graph of sine and what it looks like, and at pi it's 0, and I think about the graph of cosine, and at 0 it's 1, at pi over 2 it's 0, at pi it's negative 1. Anyway, I can just visualize that in my head, and it really helps. On the next page, it's more derivatives. What's different about these is that we don't have rules for them yet. We will in the future, but we don't have a rule for the product of two multiplied together. These are two terms kind of, or two chunks multiplied together. So currently what we're going to do is clean it up and make it look like one we can do. So what you want to do is distribute the x squared across, so that would make it 2x to the 4th minus 3x to the 3rd. And now we could take the derivative of it. So y prime, 2 times 4 is 8, 1 less than 4 is 3, and then 3 times 3 is 9. So it makes it 8x to the 3rd minus 9x squared. Okay, 52 says f of x equals 3 over, this is a cube, f of x equals 2 over the cube root of x plus 3 cosine x. All right, we're going to want to do, because it's divided by something, we don't have any rule for that yet. And honestly, this is the best way to do it. It's just float it up. So it makes it negative 1/3 and then plus 3 cosine x. Remember, when it's a root, it's to the power of that root. So it's 1/3, and it's negative because we had to float it up from the denominator. When you float something up or down, it just changes the sign of the exponent. All right, so doing the derivative of that then, f prime of x, 2 times negative 1/3 is negative 2/3, and then negative 1/3 minus 1 is negative 4/3, plus 3, again, that's a constant, leave it in front, and the derivative of cosine is negative sine. And so, I don't know, if anything, let's float the negative exponent to the bottom, so it makes it x to the 4/3, so negative 2 over 3x to the 4/3, and then minus 3 sine x. And sometimes I get questions here about this negative on a fraction. Let me remind you, it doesn't matter where you put the negative on the fraction, it floats up and down any place on it. You can have it on the top, we could have had it on the bottom, or we could have stuck it in the middle of it. It doesn't matter. This is one number. Wherever you put the negative out front, it doesn't matter. It's the negative of the whole thing, no matter where it's at. On the next page, now we're going to officially find it for a tangent line. Find an equation of the tangent line to the graph at the given point. Use the graphing utility to graph the function and the tangent line at that point, and use the tangent feature on a graphing utility to confirm your results. Again, here on 58, this isn't something that we've learned how to do, a product times a product. These are two chunks or products multiplied together, so we're going to need to FOIL it out to start with. So FOILing it out here, y is equal to x to the third plus 3x squared, and then minus 2 times both, so minus 2x squared minus 6x, and I'm going to clean it up. So I got x to the third plus x squared, and then minus 6x. All right, so now I'm going to do the derivative of it. So y prime, 3x squared plus 2x minus 6. Again, 3 in front, the 2 in front take 1 less than each power. 1 times 6, and 1 less than that made that x to the 0. And so x to the 0 is number 1. So 1 times negative 6 is negative 6. So it's just gone. All right, so we wanted to know the tangent line at it. So we're going to need to know we have the point at this point, 1, negative 4. And so again, to find the equation of a line, you need the slope and you need a point. To find the equation of a line, if you have the slope and the point, you're good to go. So we need to find the slope, and we have a derivative, so now we can find the slope at that point in time at the number 1. So we're going to do plug in at 1, negative 4. The slope is equal to, let's see, 3 times 1 squared plus 2 times 1 minus 6. So when you do the math on that, you get negative 1. And then, so you got the slope, we got the point. So again, I like to use the slope point formula. So y minus y1 equals m times x minus x1. So y minus the y there, which was negative 4, makes it plus 4, equals the slope negative 1 times x minus 1. So just distribute it across. So y plus 4 equals negative x plus 1. Now I'm doing all this work because I want to put it on in the calculator to confirm the answers like they said. So there's the tangent line. So it says find the equation of the tangent line. That was all just to do letter A. So that was letter A. Now it says use your graphing utility to graph the function and the tangent at that point. So we're going to graph them both now. So y equals, let's see, the original function was, we'll put the whole thing in there. We'll do what they gave us. X minus 2, parentheses, x squared, plus 3x, and then graph. I guess we could have put the tangent line in there too, but just, so it makes a fun little shape here. And so we want to know at the point 1, so I'm just going to double check it. So second, calculate, going down the derivative, number 6, hit enter, at 1, enter. The slope, oh, I love it when it does this. It says negative 0.9999. It's negative 1. The calculator does that. So you can use the calculator to help confirm what you did. Just be careful. It does this sometimes. It doesn't give the exact answer on the calculator. It gives an approximate one. So use some common sense when you're doing the problem. All right, and then let's put the tangent line in for fun. So y equals negative x minus 3, graph. So there is the tangent line at the point 1, negative 4. All right, 94. It says finding rates of change. Find the average rate of change of the function over the given interval. Compare the average rate of change with the instantaneous rates of change at the endpoints of the interval. All right, the average rate of change has nothing to do with the slope of the function. Not at all. It's just you're supposed to use, this is an interval. This is an x interval. So between the number 0 and pi over 6, let me graph it here. So y equals sine x. And on your zoom, change it to tangent. Well, trig, change it to trig, choice number 7. And so that makes it a little bit prettier. And then on top of that, they just wanted to know for the interval of x between 0 and pi over 6. So I'm going to change my window for fun. For x minimum, I'll make it 0. And for x max, I'm going to change it to pi over 6. Oh, but then it doesn't look very pretty. Maybe I'll go back to the trig, but it's just that little piece of the graph. So, all right, they want to know what is the slope of that, the whole line. So, but they want to know for these two endpoints. So if you took the endpoints, let me change it back to that zoom trig. So from 0 to pi over 6, for this piece of line, they want to know the slope from 0 to pi over 6 between those 2 points. Notice it's a curve, so it's not a straight line. So when we get the slope between those 2 points, it's not going to be something, it's going to be very different than the instantaneous slope at the actual endpoints. All right, so again, average rate of change, that's the slope. Let me turn the page here. So the average rate of change they're asking again about the slope. Notice again, everything's all about the slope. That's what derivatives are. They're all about the slope. So the average rate of change is about the slope of the original function, of the original f of x. So we want to find the change in y over the change in x for the original question. So the slope over this interval, 0 pi over 6, so the change in x are those numbers. I'll go backwards with it because it makes everybody happy. So pi over 6 minus 0. You could also do 0 minus pi over 6. You get the same answers, but it just makes everybody happy. So that's the change in x. And then on the top, the change in y of f of pi over 6 minus f of 0. So what is sine at 0 and what is sine at pi over 6? So on the bottom, we got pi over 6 minus 0, which is pi over 6. On the top, the sine of pi over 6, hopefully you know that and have it memorized, it's a half. And then the sine of 0 is 0. So you get 1/2 over pi over 6. So cleaning that up, it's divided by a fraction. So what you can do is flip it over, multiply the top and bottom by the reciprocal of it, 6 over pi. And then you multiply straight across. 6 times 1 is 6. 2 times pi is 2 pi. So that makes the answer 3 over pi. That's the exact answer. Or you could do the rounded answer on it. The rounded answer, if you divide 3 by pi, is approximately 0.866. So that's a rounded answer. Exact, rounded. All right, then, so that is the average rate of change. They asked for that. Find the average rate of change. There were several questions in this. So that's the rate, again, the slope of the original function between those 2 points, which is going to be different than the instantaneous rates of change. That is the slope at exactly the number 0 and exactly the number pi over 6. Again, we found it's a curve, and even though we did the slope of the 2 endpoints, it's a curve, so that's not a straight line. It's not a line. A line has the same slope throughout, but a curve does not. So just for fun here, what is the instantaneous rate of change? So we have to find the derivative of that to do it.